All right, welcome back, guys. We're going to finish up section 2.1, and as you can see, I'm actually in my office for this video. So, all right, so if you recall, we had looked at how to graph these linear equations, or we could call them functions, okay? And remember, I guess what an example of a linear function, guys, would be maybe a function that describes your total pay if you get paid hourly. Okay, so let's say you make $20 an hour and you work 1 hour. Okay, so X can represent the number of hours that you work, and then the value of Y can represent the actual amount of your paycheck. So for each hour that you work, the change in Y is always going to be $20. Okay, you work 1 more hour, you get $20 more. Another hour, you get another $20. And so because of that kind of fixed relationship there, that's how you get these lines. Okay, the steepness never changes because your rate of pay never changes. Now, of course, we would be talking about working up to, say, 40 hours, right? Because after 40, then you expectedly get overtime pay. But in any case, all right, so now what we're going to do is we're going to look at some nonlinear equations. Okay, so these are things that are going to have, and I think most of them are already solved for Y. Okay, so you don't have to worry about moving any terms around. So when they're already solved for Y, we can go ahead and call them functions if you want. Okay, that just means that the value of Y is a function of X, or depends on X. And so we're going to see things in which the X could be raised to the second power, which we refer to as being squared. We'll see, like this next one, X is being raised to the third power, which we refer to as being cubed. Sometimes you might see an X in a denominator, and whenever that happens, that can cause some really bizarre behavior in the way the value of Y changes with changes in the value of X. And then we'll look at one last one. Okay. All right, so the first one here, guys, example 4, it says, let me zoom in just a little bit, Y equals X squared minus 3. So this type of equation, whenever you have your X raised to the second power, this is called a quadratic. Okay, the quadratic function or equation, I'm going to go with function because that's the term that we're going to be using for the remainder of the course. Behavior that could be described using a quadratic function would be something like the height of an object when you throw it into the air. Okay, X could represent the number of seconds that the object stays in the air from the time at which you throw it. Okay, so you throw it, and you can start counting, 1 second, 2 seconds, 3 seconds, until it maybe hits the ground. And so a function like this would describe the actual height. Y would represent the height of the object. So we know the object would go up, and then it would fall back down. Okay, and so because of that, when we graph these types of functions, they typically have shapes that look like this, depending on their orientation. Sometimes it'll be upside down. Okay, and the shape of a quadratic function is what's known as a parabola. Okay, we'll talk more about this as well throughout the course. All right, but as far as actually graphing this, guys, we can make another table. However, though, because this is not a linear function, we're going to need more than just 2 points. Actually, it turns out you can graph it with 2 points if your first point is the center point, and then your second point is any other point. Okay, what I'm actually going to do is I'm going to choose different values of X just to show you kind of how the way this type of function behaves. And so I'm going to be a bit symmetrical about this. these are the values of x that I'm going to choose. Okay, so I'm going to let x be -2, and then I'm going to let it be -1, 0, 1, and 2. Okay, we'll plug these into x and see what we get for y. Go ahead and erase those. Alright, so a couple of these I'll do by hand, and then we may just look at the calculator to get the rest of the values. One thing I do want to show you is that whenever you're substituting a negative number in for x, it's always a good idea to keep it in parentheses. Sometimes it's necessary, okay? Because when this -2 is in parentheses, you're squaring not just the 2, but also the negative. So essentially you're saying -2 times itself, which is another -2, and that would give you a +4, okay? And then 4 minus 3 is 1. So this tells us that whenever x is -2, y will have a value of 1. Okay, so we've got an ordered pair where we know a point. Okay, now I'm going to find some other points. I'm going to plug -1 in here. I'll do this one real quick. Y equals -1 squared minus 3. Well, -1 times -1 is +1 minus 3, and that gives us -2. Okay. And guys, I think what I'll do now is just refer to the table in my calculator. I'm going to come over here to y equals. This is already solved for y, so I'm going to type in here x. The way you square something, you can do it a couple ways. You can hit this button right here. It'll automatically give it an exponent of 2. Or you can hit this button and then put in the power that you want. Okay, I'll use this one here in a minute. X squared, and then you'll say -3. Okay, and now I'm going to go to the table, and I'm going to find the rest of these values. But look here real quick. You can see this verifies -2, 1. It's right here. -1, -2. It's right here. All right. Yeah. Sorry about that, guys. But anyway, yeah. So you can see here -1, -2. We see that here in the calculator's table. And I'm just going to steal these other values. So whenever x is 0, y is going to be -3. So again, you can do these manually if you want. But for the sake of time, because I know I tend to lose your interest rather quickly, I'm just going to get these from the calculator. All right, and then when x is 2, y is going to be 1. Okay, so go ahead and write these as ordered pairs. And guys, by the way, when you're doing your homework and you're going to graph a quadratic equation or function, you don't need 5 points. You need 2 or 3, okay? And we will actually do an example in which I show you that or demonstrate that to you. All right, well, just real quick, now all I would do is literally plot these points in my Cartesian coordinate system. So -2, 1, that's going to be right here. Let's see, -1, -2, you go to the left 1, down 2. 0, -3, you just go straight down to -3. 1, -2. And then 2, 1. Okay? And now look at this. This definitely is not a straight line, is it? It is a parabola. Okay? And again, I'm putting arrows on it just to show that these tails go on forever. That just means that I can plug more and more values of x into this guy, and I'll just keep getting more and more values of y. Now those values of y will start growing really quickly. You can tell that because look at the steepness of these two tails. Okay. All right. Now you can see if I were to flip this upside down, this might be a path that an object would take if you were to throw it up in the air, okay? Like a baseball, if you were to toss it, not just straight up, but if you were to toss it with both a vertical and a horizontal component, the path of its trajectory would probably look like this, shape of a parabola. All right, well, let's go to another type, example 5. So you see here, this one is not a quadratic function. This is what we refer to as a cubic, because x is being cubed, or in other words, raised to the third power, okay? So the shape of this one, guys, if we were to graph this relationship between x and y, it's not going to be a straight line. It's not going to be a parabola. It's actually going to have more hill-like behavior. Typically, these cubic functions will kind of go up. Sometimes they'll take a dive down and then go back up again. Or sometimes they may just go up, kind of level out, and then start increasing again. Okay, depending on the orientation, of course. All right, so for this one, I'll just choose those same 5 values of x, just to be consistent. -2, -1, 0, 1, and 2. How's that? And I'll work a couple out again, as always, by hand. I'm going to plug in -2, but now I'm going to be cubing it. All right, well, -2 cubed means 3 -2's multiplied. -2 times -2 times another -2 is actually a -8. And if we take 2 away from that, we're going to get a -10. Okay, so that gives me an ordered pair. I'll do one more, I guess, by hand. Y equals, I'll plug -1 in, cube it. -1 cubed, guys, is -1. Hold on just a minute. And -1 minus 2 is -3. Okay, -1 comma -3. All right, and then I think I'll just utilize my calculator to find the rest of these values. All right, so I'm going to clear this. I want to now cube the x. So to do that, I can come to this key. This will allow me to raise it to any power I want. So I'll put a 3 up there. But you need to make sure you move your cursor. So you're going to click to the right, and then you're going to put in there -2. Okay. And then we can go to the table again. And you can see those 2 ordered pairs are confirmed. Then we've got 0, -2. Let's see. We've got 1, -1, and then 2, 6. Okay. Now, when you're graphing these cubic functions in your homework, I think that you may need 4 points for these. Okay. All right, well, let's plot these ordered pairs. -2, -10 to the left, 2 down 10. -1, -3 to the left 1 down 3. 0, -2, that's sitting right on the y-axis. 1, -1, be to the right 1, down 1. 2, 6 to the right 2, and then up 6. And now look at this one. This one's not a straight line either, nor is it a parabola. It actually behaves like this, guys. Kind of comes up, comes over. It actually really almost becomes level right there, and then starts to curve up again. Okay, so remember, kind of heel-like behavior, except this is a really steep heel, isn't it? So that's the way these cubic functions behave. Sometimes they might look like this. Okay, they might have one peak and then one valley, or sometimes like this one, they may come up and then just kind of go straight across and then go up again, something like that. Or if they're upside down, they might come down and then go back up, something like that. Okay. So that's kind of how these behave. Let's actually go ahead and graph this one in the calculator. Yeah, looks like what we got, doesn't it? You could have done that for the previous example as well. Alright. Trying to think of it, because it's hard, you know, when it's not a live class, to think of everything you want to say. But anyway, so we've seen some linear functions. Okay. We've seen a quadratic function right here. We've seen a cubic function. Now we're going to see two more types. This one right here, guys, is called a rational function. And we're really only going to see this maybe this one time until we get later into the course. Okay. What makes it a rational function is the fact that there is an x in the denominator. Okay. And that can also make this one tricky when it comes to picking values for x. Because it would be easy to get fractions. So for example, if I put a 5 in here, then my value of y is going to be 3/5. And those fractional values of y are going to be hard to plot. Okay. So what I will do is maybe I'll start with, well, I know, let's start with 0. Okay. I want to illustrate something here. So if I plug in 0, what is 3 divided by 0? Most people will tell me that it's 0, but that's not right. Let's see what the calculator says. It gives us an error. And the reason it gives us an error is because this operation is not possible. In fact, guys, we say that division by 0 is not defined. Because essentially you're saying this, how many times does 0 go into 3? Well, 0 doesn't have any value, or it doesn't have any substance, so to speak, so it would go into 3 infinitely many times. Okay? So anything divided by 0 doesn't exist. It's not a real number. Okay, so 0 is not going to work. And so that means we're not going to have a point either above or below 0 on the x-axis. Okay, so then what do I pick? Well, I can look at this and I can say, well, I could divide 3 by 1 or negative 1. Okay, so maybe I could use those values, negative 1 and 1. If I plug negative 1 in, I'd have y equals 3 divided by negative 1, which is negative 3. So that gives me a point. And if I plug positive 1 in, 3 divided by positive 1 is positive 3. So that gives me another point. So I've got 2 points. And I could go ahead and plot those, negative 1 comma negative 3. And then 1 comma 3. But this doesn't tell me much. This is not going to be a straight line. So what else could I do? Well, maybe I could pick, let's see, what else would go into 3? Maybe 3. Actually, I should have put these in different places, but anyway. Maybe 3 will. 3 goes into 3 one time. Okay, so that gives me another ordered pair. So I'm just kind of thinking about this out loud. And then maybe negative 3. If I plug a negative 3 right here, 3 divided by negative 3 is negative 1. So that gives me another ordered pair. Okay, and then of course you can use your table. Let's look at the table. And go to, oops. I'm going to type in here 3 divided by x. And you can see, look right here, guys, whenever x is 0, we get an error. We say that this function is not defined for 0. We'll talk more about this later. But you can see when x is -1, y is -3. And if I come down here, when x is -3, y is -1. So for one like this, you might want to use your table or just graph it in the calculator. Let me plot these other 2 points real quick. -3, 1, or -3, -1. To the left 3, down 1. And then 3, 1, to the right 3, up 1. And so if I hadn't already looked at the calculator, I would think, well, this looks like if I were to connect the dots, it's just going to give me a rectangle. But it's not. So you want to graph this one in the calculator. And actually your homework problem is multiple choice. Okay, so you will not be manually graphing it. It actually behaves like this, and that's why this is such an interesting class of functions. It's split into 2 pieces. And the reason it's split, guys, is because 0 is excluded from being an input. So that means there is no point right here that might connect these 2 pieces. Okay? And so they actually behave like this. This is what we refer to as asymptotic behavior. The left side kind of dives down to -infinity, and the right side kind of goes up towards positive infinity with respect to the y-axis. Okay, so like I said, don't get too bogged down with this one. We'll study them in more detail toward the end of the semester. All right, well, let's look at one last class of functions that we're going to talk about. You may have seen this before. These vertical lines right here, guys, you may think, well, this looks kind of like a linear function because nothing's being done to the x. It's not being squared or cubed. It's not in a denominator. But there are these bars around the x plus 2. These are what we call absolute value bars. And this is called an absolute value function. Okay? And what absolute value bars do is they take whatever's inside them and they make it positive. Okay? So if there's a negative number sitting inside here, they make it a positive. But if there's a positive number sitting inside here, then they just keep it positive. Some students erroneously think that they change the sign of whatever's in here, but that's not true. They only change the sign if there's a negative inside. Okay? And because they turn everything into a positive, these are sort of like linear functions, as you'll see here in a minute, but it's like they're made up of 2 lines. Okay? Because they take everything that's in here and turn it into a positive, this function, when we graph it, will stay above the x-axis because all the y's are going to be positive numbers. All right. Now, I want to give you a tip on how to graph these, because if you don't do it this particular way, you're going to have some issues in the homework. Whatever you want to start with the center point. The shapes of these functions are going to be these. Okay, so they're going to look like this, or they could be turned upside down. Okay, and they're going to be positioned on the x-axis somewhere. Now, the center point is right here. That's the point that you want to start with. And so you may be saying, okay, well, how do I figure out where that point's going to be? Because I haven't graphed it yet. I have no idea what it looks like. Well, guys, the value for x for which that absolute value function will be centered is always going to be the opposite of that number. So if that is a positive 2, then I will use a negative 2. Okay? And so let's try this. Let's see what we get. So if I plug in here y is equal to the absolute value of negative 2 plus 2, well, negative 2 plus 2 is 0. So then this becomes the absolute value of 0. Well, guys, 0 doesn't have a sign. So the absolute value of 0 is 0. Okay? And that kind of shows you the fact that the y coordinate, or the value for y, is 0. that will be your center point, and that's going to be right here. Now, to graph these in your homework, all you need is one other point. Okay? But what I'll do real quick is I'm going to pick two values of x that are less than -2 and two values of x that are greater than -2, just to try to be symmetric. Okay, so I'll use -3 and -4, and then on the other side, -1 and 0. If you remember what your number line looks like. All right, I'm going to do a couple of these by hand. So let's plug in -3 next. Okay. -3 plus 2 is -1. So this gives me the absolute value of -1. Well, the absolute value will make that a positive 1. Okay. And I'm going to do one more as well. Let's plug in -1, and then we'll get these other two from the calculator. So y equals the absolute value of -1 plus 2. -1 plus 2 is 1. And the absolute value of 1's already positive, so it's going to stay positive. Okay, so -1, 1. All right, so I'm going to get my last two values of y from my calculator, because I want to show you how to graph these types of functions. All right, so where do we get the absolute value symbols? Well, right here. You go to the math key, you go to the right where it says number, and you select number 1 for absolute value. And it'll put them in there for you. And then you just need to type in there x plus 2. Okay? And now I can go to my table if I want. And we can see, all right, when x is -4, y is going to be 2. And then when x is 0, y is also 2. These functions are symmetric about that center point. Okay. All right, so if I were to plot all these points, -4, 2, go to the left 4, up 2, go to the left 3, up 1, go to the left 1, up 1, stay at 0, and then go up 2. What does that look like? Well, it sort of looks like a parabola, but it's not. It's actually two straight lines converging at that center point, like that, okay? So it's kind of like the line comes down, hits the x-axis, and bounces back up. It bounces back up because all the y values have to be positives because of the absolute value operator right here. And then just real quick, you could hit the graph key in your calculator. Look at that. And guys, if you're not sure what the center point is, just graph it first, and then you can see right here. It's whenever x is -2. Okay? All right. Okay, so I'm getting close to 30 minutes. What I want to do now real quick is I want to go into the homework. I want to show you how to graph these using the software. I'm going to have to go in as an instructor, though. And let's just arbitrarily pick question 3. Okay, question 3, -2 times x squared. Okay. All right, well, because the x is squared, this is a quadratic function. You've got to know the type before you're able to graph these, because you have to click on the correct graphing tool. So right here it says 3-point quadratic tool, so that means it's going to require 3 points. Over here it says 4-point cubic tool, so when you're graphing a cubic function, you're going to need 4 points. You're not going to worry about the circle, but you will also need the absolute value tool. Okay, So I'm going to click on the quadratic tool. And what I'll do just real quick, guys, is I'm just going to put this one into my calculator. It's negative 2 times x squared. Make sure you hit the negative 2x and then square it. And then go to your table if you want. Alright, so I just need a couple points. I think the center point is going to be right here, 0, 0. And you do have to plot that center point first. So I'm going to click once right there. Now see what's happening after you get 1 point. When you put a second point, you're only going to get a line. That's why you need a third point to give this curvature. Okay, but make sure that that first point is the center point. Okay, so graph it in your calculator if you need to. See, if I needed to, I could graph it and kind of see its orientation. All right, so I'm going to go back to my table now. And I just need to get a couple more points. Why don't we do this one, negative 2, negative 8. Okay, so I'm going to start here. I'm going to go to the left 2 and then down 8. Remember, you're not clicking until you get your cursor where you want to put that point. Okay, so now you can see, depending on where I put that third point, it'll give my parabola the shape that it needs. Let me look back at my table. I'm going to choose a point on the other side, maybe positive 2, negative 8. So I'll go to the right 2 and then down 8. And there we go. That's where I want to put it. And that fixes that shape. And then you can save it. Okay. All right. Let's see. Question 4 is another quadratic. Question 5 is a rational function. Like I said, this one's multiple choice. Question 6, this is an absolute value function. Okay, so let me help you out on this one. So on this one, I need to know, well, where is the center of this guy? Well, if you look right here, it says negative 7. So the center is going to be whenever x is positive 7. But if I'm not sure, I can do it in my calculator. I'll come over here to math, go to number, down to 1 for absolute value, and we'll type in there x minus 7. And go to the table. Or actually, I'll graph it real quick first. So yeah, so you can see right there, that's the center at 7. Okay, so when I go to the table, I'm going to be looking for 7 in my x's. Right there, I see it, 7, 0. Alright, so when I get ready to start putting some points, I need to grab this tool, the absolute value tool, because this is an absolute value function. So my first point, I'm going to put at 7 right here on the x-axis. Now you can see, depending on, because my first point was in the center, depending on where I put that second point, it'll fix the shape of that absolute value function. So now I just need some other point. Let's see, why don't we use 4, 3? Okay, so come over here, I'll go to the right 4, and then I'll go up 3, and now I'll click. And so now I've got that shape. And I'll save it, and I'll check my answer, and I got it. Okay. And I think question 7, oh yeah, let's look at 7, because it's an example of a cubic function. Okay, so for that you need this tool, the 4-point cubic tool. Okay, and you're going to need 4 points. Now, these cubic functions, they sort of have a center point, but I don't think it matters whether you plot it first. But I am going to put that function into my calculator. X to the 3rd power plus 1. And then we'll go to the table. And I'm just going to maybe, let's do 1, 2 first. Okay. So here, go to the right 1, up 2. There's 1 point. Go back to my table. How about we do 2, 9 next? So I'll go to the right 2 and then up 9. There we go. Now so far I'm just getting a line because I've only put 2 points on it. A third point will turn this into a quadratic, and a fourth point will turn it into a cubic. So I need a couple more points. How about we could do -1 comma 0. Just go to the left one and then not up or down. Click. And I need one more point. How about I do -2 comma -7. Start at the origin, go to the left 2, and then down 7. And look, that creates this this cubic shape, doesn't it? See how that has that characteristic cubic shape, kind of goes over, kind of levels out, and then starts increasing again. And you'll just click on save, check your answer, and we got it. Okay. All right, guys, so make use of that calculator. I encourage you to go ahead and try to do these by hand with your XY table. But you may need to put these in the calculator at least to give you an idea of where the center of that function is going to be, especially for absolute value functions, and then also for possibly quadratic functions. Okay. All right, so I went a little bit over a half hour, so I think I'm going to go ahead and stop it there.